All right. So suppose you want to evaluate the security of hash algorithms. How likely is it that you'd hash two things and get the same answer? Well, if you have some hash like MD5 or SHA-1 or something, you start with some text and you hash it, and then you hash the hash and hash the hash. This is one possible way to generate apparently pseudo-random things. Well, then at some point, you will have two values that hash to the same thing. And when you do, this will hash to something, and somewhere along the line, somewhere in the future, you'll have another thing that hashes to the same thing, and therefore you will get stuck in an endless loop here. This is why they call it the row. This resembles the Greek letter rho. And it turns out that statistically, the size of this tail is approximately the square root of the number of possible hashes, and the circumference of this loop is approximately the square root of the number of possible hashes. So that gives you an idea how long it's going to take for this to happen. And you can now evaluate the security of hash algorithms by doing this. So, for example, we can calculate an MD5 hash. Here's how you calculate an MD5 hash in Python. There might be other ways to do it, but this is the way I found to do it. There's always a lot of different libraries that'll do it. So this is going to encode the word A. I'm going to have a single letter A, and I'm going to get the MD5 hash of it. So there it is. All right. And now, when I try it here, if I just try an online generator to back it up, it should start with 0cc1. And it does start with 0cc1, so I've got it working correctly. I always like to check it with another source. So now we're going to truncate that hash. Because if I use an MD5 hash, it would take millions and billions of calculations to see that row shape, and I don't have that much patience. So I'm going to make a shorter hash from it. I'm just going to overwrite this code with this code where I do the same thing, but then I truncate it by going the two characters from the end to the end. So now I get 61, just the last two characters. So I've got a 1 byte hash that only has 256 possible values. All right, and now I can do iterated hashing. I can do 50 iterated hashes here, where I just do the hash and then hash the hash and hash the hash to perform that operation that I was just describing. All right, and so there they are, a whole bunch of hashes. Now, it might not be obvious whether this has repeated or not, but one way to deal with it is put it in a text editor. And if I was running it in a local, Python environment, it would be in like a terminal window that would wrap around. In this case, I'm having to copy and paste it into a text editor. So here's a text editor. The only thing getting me now is I'm having a little trouble copying the results out of this thing. I think I have to use Command-C. The right-click menu in this weird Colab thing doesn't seem to include normal copy and paste. There we are. So there's the numbers. And what you can do is just adjust the size of this window until you see duplicates. There, 21, 21, 21. When you get it right, you'll see here's the tail up to 87, 60, 8A, and here's where it starts repeating. So it took, I'd expect it to take the square root of 256, which is 16. So that looks about like 16, around 16 characters in the tail. And now I'm in a loop, which is around 16 in length as order of magnitude. So that shows how the row method works. And there are just some other challenges here. You can start with a different value. You can try 3 characters or indeed a 32-bit hash. And of course, the challenge is you can do the 3 characters this way, but the 32-bit hash, it's really going to be a lot of calculations, and you're going to have to write a code that will notice when the duplicates happen. You're not going to be able to just eyeball it. So anyway, that gets you introduced to this row method construction, which is used quite a lot in cryptography, dealing with how hashes are handled and how to do things like crack password hashes. This explains something I've seen before. When I used Offcrack, which is a tool to crack Windows XP password hashes, I was surprised it doesn't try guesses words one in a row. It has a strange random looking pattern of words because it's doing this actually. Hash of a hash, hash of a hash. Anyway, that's the row method. I'll stop this one.